Hello, everyone, and welcome. Thank you for joining us today. Just waiting for a few more people to join before we start. The weather's looking good here. I don't know what it's like where everybody else is. Hopefully good too.
We're getting much needed rain, at least in the southeast, which is great.
Got a few more people coming on now. That's great. Well, it's 3 o'clock here in the UK. So this is the time we're going to start. So I might as well start here. Just to say hello to everybody and welcome, and thank you for joining us today. I'm Louise Scott, Global Marketing Manager of IPS Adhesives, and I'll be the moderator today. Joining us to talk through our presentation is Taylor Santa, Technical and Sales Support Specialist, and Sean Kennedy, Business Development Manager. So here, how it'll run today, we'll start the presentation from Taylor and Sean. It'll run for about 25 minutes, followed by a question and answer session at the end. We'll be taking questions through the Q&A box. So if you put them in there, and we'll answer them at the end. Any questions that we don't answer today, we'll send you by email. Just to let you know, the session's going to be recorded today and shared with our attendees afterwards. So without further ado, I'll pass you over to Taylor and Sean.
Hey guys, so today we're going to talk a little bit about solving plastic bonding challenges with MMA adhesives. I'll introduce myself first. So my name is Taylor Santa. I graduated from Western Carolina University with a degree in chemical forensic science. I have been working in the adhesive, especially MMA adhesive world for about 8 to 9 years. Kind of starting in quality control, kind of working my way through application testing, R&D work, and now am the technical and sales support specialist, basically just bridging the gap between sales engineers and our R&D team. Pass it over to Sean.
Okay. Thank you, everyone, for attending. Again, as Taylor and Louise mentioned, my name is Sean Kennedy. I'm the Business Development Manager for IPS Adhesives. I've been, crazy to say, but I've been in the adhesive world for over 25 years, and I'm only 35 years old. So, but I think that's when that picture was taken. So, but I have experience. I've been bonding plastics and everything under the sun. Starting in the pressure sensitive world with double-sided tapes, and the last 20 or so years in the structural adhesive market. And so we'd like to be a resource for our customers and our distributors in finding the right adhesive for your application. So we appreciate everyone attending, and hopefully you get a little bit of knowledge throughout this presentation. But as Louise mentioned, any questions or specific issues, please pop them in the chat box, and we will get to them. So next slide, please. Okay, a little bit about IPS Adhesives. We have been in business for well over 65 years now. We have locations in both North America, in Durham, North Carolina, and in the UK, in Newcastle upon Tyne. These both facilities that you see there are manufacturing centers of excellence, and also laboratories we have there to do testing, which we'll talk a little bit more about. So we've been in business for quite some time. We have a lot of experience just on our team in North America alone, just with 3 of us, Taylor, myself, and another gentleman. We have over 50 years in the adhesives and coatings business. So again, partnering with our customers and distributors to find those right adhesives. So next slide, please. So what are we going to be talking about? Why did you invest your time this morning here or this afternoon? We're going to talk about the overall bonding of plastics. Adhesives, as we all know, can bond to many different materials, but plastics can be something that we do want to talk about a little bit more in detail. Plastics and adhesives are used more and more in every single industry and will continue to be so in the future. So we'll get into that a little bit. But there are challenges involved with bonding different types of plastics and materials into similar substrates. So we'll talk about those challenges and how side grip adhesives best works towards finding you the correct solution. Obviously, today's focus is going to be on MMAs, but we'll talk a little bit about some of the other ways to bond plastics and other types of materials. With adhesives, we want a structural bond, and MMAs give you that, and we'll talk a little bit about the reasons why. And then obviously, and more importantly, we'll talk about the products that we have that address this market and the industries that we serve that will be a great fit for your applications. Next slide, please. So what the heck is structural plastic bonding? Again, there are many different types of products, adhesive products that are out there. Could be, your super glues, could be your moisture cure products. But when we get into, and anything will bond, but when we get into a structural bond, we're looking to get such a strong bond that we want to basically destroy the plastic when we try to take it apart. No, we don't have a product that we can give you the strongest product that there is, but it's going to be difficult to get it apart. And there's no magic pixie dust that will take those products apart. So these are structural, long-term, long-lasting bonds that will last the life of your part. They're designed for harsh environments. A lot of our products, one of our most famous products that's most popular products is used in the marine industry. A lot of impact, shock, a lot of environmental concerns, temperatures. MMAs stand up to anything in these types of industries, transportation, again, marine, industrial, and it's used and trusted by OEMs across the globe. And again, the nice thing about when you use a structural adhesive, you're lightweighting the part. You're bonding and sealing. Taylor will talk a little bit more about some of the other ways of joining materials together. And if you put a hole in something to use a mechanical fastener, you're creating a leak path, and you're creating a weaker overall assembly, that has a hole in it. So when I'm going to turn it over to Taylor here, but when we look at structural adhesives, we want the strongest overall bond to make your part more cost effective, more production friendly, and last the life of what you're putting out into the industry that you're working in. So with that being said, again, we appreciate your time. Taylor, you want to take it from here?
Thank you, Sean. So first thing I kind of want to bring up is just there are many, many, many types of plastics in the industry. I'm going to kind of break them down into kind of two separate groups: plastics that are easy to bond and plastics that are a little bit more difficult to bond. Most of these plastics are used every day. I mean, these are the 8 most common plastics that I deal with on a day-to-day basis. Things like acrylic, ABS, PVC, polycarb, PET, and polystyrene. All of these plastics are easy to bond to. And the reason for that is they actually have a higher surface energy, which we'll go into a little bit more detail later. And we're kind of using Dyne's levels to kind of measure that surface energy. So these plastics range from the lowest of 36 to 42 Dynes per centimeter. These are all very lightweight, versatile, strong plastics used in, I think, just about every industry. The next group that we're going to talk about is the difficult to bond to plastics. So in contrast to these other ones, these are a low surface energy plastic. And like I said, we'll kind of get into a little bit more about what that means. These are polypropylene, polyethylene. There are also hundreds more, but these are the two most common that we see. They are both below 31 Dyne per centimeter. At this level, the adhesives tend to kind of bead up. We don't really get good wet out when you're trying to bond. Because of this, a standard bonding approach often fails unless you take some additional steps like surface treatments, primers, specialty adhesives, or even just mechanical fastening. So the key kind of takeaway for these two slides is bonding materials, especially these low surface energy materials, it isn't impossible. You can bond them, but it doesn't require a little bit more process control, a little bit more effort, and a little bit more of a specialized adhesive across the board. So different types of plastic joining, mechanical fastening, everyone knows, just take a screw, drill the two pieces together. Like Sean was talking about, this will actually lead to more leaking if it's something that's going to be holding water or anything like that. They are really easy to use, though. They're very low cost. They do add a bit of weight to the final product. So if you're trying to keep the weight of your product low, this really isn't ideal. This also will damage the substrates. Obviously, you're going right through. So that damage actually creates a weak point. So if this product is seeing a lot of vibration or a lot of impact, the likelihood of that joint failing within the lifetime of the part is very, very high. Also, this might be a personal thing, but I think the screws and bolts kind of give a very poor aesthetic. The next type of joining we're going to talk about is solvent cements. They're very simple, typically a one-part system. They are very low viscosity, so they're either water thin or almost maple syrup in consistency. It's very easy. You kind of brush it on, stick the pieces together, and they're very quick to cure. These are great, but they are very limited into the types of plastics that you can use. So you can use this with your bonding, let's say acrylic to acrylic, but if you're trying to do an acrylic to a piece of metal or an acrylic to a polypropylene or something like that, they're not going to work. So it's a very specific product for a very specific bond. And just due to the nature of these, this chemical, there's a little bit of environmental concerns. Next, we're going to talk about ultrasonic welding, which is basically high frequency vibrations that heat up and basically fuse the two pieces of plastic together. It's a great process. It is very strong, and you don't use any consumables in it, but the initial investment, the initial capital investment in getting something like an ultrasonic welder is very, very high. It takes up a lot of space. It takes very, very specific training and specific people to be able to use these efficiently. And you have very, very tight design constraints. There's not a lot of gaps that you can fill, anything like that. And the last one we're going to talk about, which we're all here for, is adhesives, mostly two-part adhesives. The good thing about adhesives is you can bond to similar materials. You don't have the poor aesthetic of mechanical fasteners. You don't have a weak spot like mechanical fasteners do. It's a lower equipment cost, typically just using either a hand mix or shooting out of a cartridge or a meter mix dispensing machine if you are bonding large parts. Some cons about adhesive, though, they are a little bit slower in the cycle times. You have different working times. It takes a little bit longer for those to set up, and there is often squeeze out whenever you're putting the pieces together, and that requires a little bit of cleanup afterwards. So some challenges to think about whenever you are choosing a way to join plastics. You want to think about the size and the shape as well as the thickness of these parts. If you have a very, very thin gauge piece of plastic and you're putting, let's say, an adhesive that has a very, very high exotherm or reaction temperature, you are going to see print through. You're going to be able to see that joint and where the adhesive is laid down. You can see in that picture where the finger is pointing, that's actually a little bit of warping because the exotherm was too high and distorted the finished look of the part. You also want to think about working times. How much time do you have to get these pieces together? How much flex is going to happen in the lifetime of the part? What are your gap sizes? Are they inconsistent? Sometimes molds don't always give 100% exactly the same thing every time. So being able to mitigate the chance of inconsistent gaps is very necessary. And then there's also some surface challenges, as some plastics are very shiny, and there is often mold release when you're manufacturing these plastic parts, and that can be a little tricky to get good bonds to. So the biggest challenge, though, out of all of these is just your surface energy and whether adhesives are going to bond well to these plastics. So surface energy and Dyne's level, low surface energy really just is about 36 Dynes per centimeter and below. Anything below that, what's going to happen is basically you could tell if you take a little bit of water, sprinkle it on the part, if the water beads up and kind of forms a very, very circular bead on the top, it's going to be a low surface energy. So basically the molecules of that plastic they are not compatible with the material that's coming on it. So it's kind of forcing the surface tension to keep that bead in a more circular shape. If it kind of flattens out and smooths out a little bit, it's a high surface energy, and it's much, much easier to bond to. So one of the ways that you can kind of negate this low surface energy and just help bonding across any type of plastic is just doing different surface treatments. And there is a wide range of what you can do. A lot of people think you don't have to prep a sample. You just kind of, here it is. It's got the mold release on it. It's got all this dirt and dust that gets kicked up in the factory, and they slap some adhesive on, put it together, and then it fails. What's happening there is you're not getting a good interaction between the adhesive and the surface of the plastic itself because there's a barrier there, whether it's mold release, dust, oils, dirt, anything like that. The next type of surface treatment, which is the most common seen in most plastics other than low surface energy, is just cleaning the surface with a solvent. This can be IPA, isopropyl alcohol, or acetone. Basically, all you're doing is just getting rid of any contaminants on the surface to give the adhesive a better chance of actually interacting and bonding with the surface of the plastic. The next thing you can do to increase your strength and increase your adhesion is light abrasion. So just taking a little bit of a sand to it. So the abrasion will significantly increase the surface area of the bonding. Another benefit is with sanding is if you sand down a little bit, you are getting rid of a lot of that mold release, and it's difficult to get rid of that with just the IPA. So if you sand down, you're going to get rid of a lot of that mold release. You're going to give more surface area and more chance for the adhesive to bond well. One reminder with sanding is you should really clean the surface first, give it a sand, and then make sure you do wipe it down again with a solvent, just to get rid of any of that dust that you kick up, any of the particulate that comes off when you are abrading. Another type is actually physically changing the surface of these plastics. So stuff like corona, plasma, and flame treatment, all of these basically change the chemistry of the top layer, the top molecules of the plastic, lending to easier adhesion. These are great, but they are very expensive to send out and get. There's also a shelf life after these plastics are treated. If you don't get something done within that shelf life, it's like you never did it. So it is a great way, but it is very, very expensive and very difficult. The last thing is primers. Primers are basically you clean the surface, wipe it down with one of these liquid primers, let it dry, and then you're ready to bond. These primers add a thin coating of a functional material so that one of the molecules bond very well to the plastics, especially low surface energy plastics, while the free ends bond very well to the adhesives. So when you're thinking about using adhesives in plastic bonding, there are 3 different types of adhesives that are pretty much the most common. Those are MMA, epoxy, and polyurethane. So I always like to just kind of give a review of what's the difference between all of these. We hear all the time MMAs confused for epoxies, confused for urethane. You hear it quite often. Epoxies are very, very high strength adhesives. They are probably they are one of the higher strengths of all adhesives because the strength is so high. They do become a little bit more brittle. So if your part is going to have vibrations or impacts or anything like that, the chance of it breaking during that is very high. Polyurethanes, on the other hand, they're not as high strength, but they are incredible with impact and vibration resistance. So MMAs kind of came in to kind of bridge that gap. They are very high strength. They withstand impact, vibrations, anything like that. So they kind of bridge the gap between the epoxies and the polyurethanes. All right, so now we'll kind of jump into just some of our products that work very well within the plastic bonding world. First, we're going to start with the SG300. This is kind of a legacy product. It's been around forever. It's a 2-component non-sag MMA. It's a 10-to-1. We have it in multiple working times, between 5 and 40 minutes. It comes in 2 different colors, and it cross bonds a variety of surfaces without the need for much surface treatment. All you really need to do is wipe down with a solvent like IPA, and you are ready to go. And that goes for plastics, metals, composites. This product works really well in plastic bonding. The plastics will break before the bond itself breaks, and it was designed to meet the specific requirements for transportation industries, including having a very low exotherm or released heat during the reaction, so you don't get that print through and that read through on exposed visual surfaces. I like to think of the SG300 as kind of the workhorse in all bonding. You can kind of use it for pretty much any bonding you are doing within an entire shop. So that's why that's a really, really great product. Next is the SG5000. This is a 1-to-1 MMA. This is Sean's favorite. It comes in a 6 and 13-minute working time. It's very, very good at bonding plastics, and as well as metals, composites, and doing cross bonding of all of them. It's very simple to use. It has a little bit lower of a viscosity, so it flows a little bit better. It's injectable, which is great. It's a very high strength and very high tensile strength and shear strength. This product is a really strong metal bonder, but we've seen more and more customers using it in plastic and cross bonding between plastics and metals in the industry, and it's been received very well within the industry. Now we're going to get into some more specific. They have more of a specific avenue. So the first one is the Weld On 46 Clear. This is an optically clear 2-part MMA, high strength. We see this used a lot in the sign industry. You can see in that picture in the top, that's a piece of aluminum and a piece of acrylic bond on top of each other. So if you have something like that and you have a light shining through it, you're not going to be able to see the bond. So it's really great in those highly visible areas. It is approved through UL for electrical sign assembly, and it's really great for trim cap and polycarbonate lettering. So anytime you're going to need something that is optically clear and you're going to have that light shining through, this is a really great product. All right, so next is the SiGrip 400 LSE. We talked a lot about low surface energy products or low surface energy plastics and how they're difficult to bond to. This adhesive was designed to bond low surface energy products. It's a 2-component 10-to-1 MMA. It bonds everything, polypropylene, polyethylene. We even ran a test where we bonded a piece of metal to a Teflon pan and hung a weight off of it, and it stayed strong. So not only can you bond low surface energy plastics, but you can also cross bond with metals, which helps a lot to have something like that where you can use it in multiple different spaces. It simplifies the process, saves on labor costs because you don't need flame plasma treatments or anything like that. It's used a lot to fix pinholes in tanks, doing repair jobs. And I'm going to play a little video about bonding the car doors, some polypropylene car doors. So one thing I just kind of want to mention with a lot of these products, well, I guess with the LSE specifically, this is it's a little different than some of our other products. It does take 6 hours before you can remove the clamps. And then it takes 24 hours to get that full cure. So it's just kind of a little reminder for the 400 LSE. Pass it over to Sean.
Okay. Great job, Taylor. Thank you very much. Good stuff. So how can we help you? How can we support, if you're a distributor, how can we support you and your customers? If you're a customer and looking for another solution, what we can do to help you is one of the things I've found in my career in adhesives is that too many times customers, when I ask, why are you using that adhesive? And they say, well, that's what we've always used. And parts change, geometries change, surfaces change, the types of plastics that Taylor mentioned can change, especially we deal with a lot of contract manufacturers. So as things change, don't necessarily think that you can use the same adhesive over and over and over again. Always take a step back, contact your friendly side grip representative or distributor, and we can work with you to make sure that you're using the right product the first time. And how we do that is on-site training. We're happy to come to your facility, do a line survey. What are you using now, whether it's another type of adhesive or another type of bonding process, or just conventional methods of putting two parts together. We can understand what you're doing and how to optimize your process with the right adhesive. The process optimization, that is something that we do. Taylor is actually involved in writing a customer standard operating procedure, their SOPs, because they went from a 24-hour moisture cure system to a 15-minute curing. And, that has radically changed, how they do things and, their work in process. So that is, we can help with that. Obviously, lab testing. If you have parts, you can certainly do some quick testing. We're happy to send samples. But if you want us to be more involved and want some numbers behind the adhesive compared to what you might be doing now, strength numbers, we have in both facilities in Europe and in North America, we have the ability to do all that type of analytical testing for you. But again, it's getting back to working closely with you, finding the right solution, and making sure that it's cost effective for you to do, and it's going to increase your quality and the performance of your parts out in the industries. Obviously, we have a ISO 9001 quality management system and other types of approvals worldwide. So our products are used on every continent, and so we're happy to work very closely with you. And again, we appreciate your time. We thank you for attending this webinar. And with that being said, I'll turn it back to Louise. And if we have any questions, we'd love to answer them for you now.
Yeah, thank you, Taylor and Sean. At the moment, we have no questions in the Q&A, but if anybody wants to drop a question as we finish the presentation, we'd be happy to answer them. So I'll give you a minute or so to see if you want to put any questions in there.
While everyone is thinking about questions, if you think of something later, just feel free to reach out to us. If you don't have our contact information, you can actually go to our website and there's an Ask SciGrip button. Just hit that. Those emails will come to myself and my counterpart in Europe, and we can get those questions answered for you as quick as possible.
Yeah, it's a good point, Taylor. With also on SciGripAdhesives.com, there is a product selector guide. So if you do want to, jump on that, and if you're trying to bond steel to ABS, it'll come up with a possible solution for you, and then we'll be happy to get you a sample.
Well, that looks great. Doesn't look like there's any questions at the moment. Just to say thank you to Taylor and Sean for all the insights that you've shared this afternoon. And also thank you to everybody else for joining us. We really do appreciate your time and participation. We'll be sending out the recording and any relevant resources shortly. If you'd like to continue the conversation, like Taylor said, go to our contact us page, and be sure to follow us on LinkedIn or check out our side website resources page for more content like this. Thanks again. We hope to see you next time, and enjoy the rest of your day.
Have a great day, everyone.
Thank you very much.
Thank you.